in today's class, we will discuss about measure of dispersion. Okay, so see the example given to you. The example here is 20 employees average salary is 30 and 10 employees average salary is 4,000. Now, can you tell which company is providing better salary? Can you tell which company is providing better salary? So in that situation, you can't directly tell 20 employees of wherein the average salary is 3,000 is providing better salary. So that conclusion you can't come. That means whenever you want to compare two different datas, here there is factory A and there is factory B. The salaries given in factory A to the each employees are completely different to the salaries which are given to the factory B. So with the mere assumption of seeing the average salaries, you can't compare the two data. Therefore, measure of central tendency fails to compare two different data. As the measure of central tendency fails to compare two different data, we need to learn some concept called dispersion. So dispersion helps to compare the two different data, and it also helps to know the amount of variation which is taking place. See what kind of variations will be there now whenever you sleep. Early morning when you wake up, three things you might feel. That is, number one, you might feel happy and you might give a small smile. Or another situation is there, normal, that is no happiness is there and you are not, the mood is wherein you are not crying also. So both are balanced, that means you are normal. And there is another situation there, you might when you wake up you might feel sad. So three situations arises. Similarly, in the in the given observations, always there might be three types of variations which can take place. That is a positive variation, that is when you are happy you will be positive, when you are sad you are negative, and when you are neutral there is no variation taking place. Therefore, whenever any given set of observations are there, to measure the variations are positive, or to measure the variations are negative, or to measure whether there is neutral variation, that means all observations are having slight variation with the given set of with the central tendency. So to know that, we need to learn dispersion. That means here, point number one, why are we learning dispersion? Dispersion is used for comparing two different data. Under central tendency, we will not be able to compare the two different data, because of which we need to learn dispersion. Similarly, to measure the amount of variation or deviations which is there in the given set of observation, to measure that we need to learn dispersion. That is why dispersion are also called as, dispersion is nothing but variation, that is nothing but the amount of variation of the given set of observations from the central tendency is measured under dispersion. Therefore, the definition of dispersion is nothing but, dispersion is nothing but scatterness or the variations which has been measuring the items from the various measure of central tendency. It helps us to know. Here let me take an example. The examples are like 200 and 300 and 400, 500, 600. So there are five observations are there. Out of these five observations, if mean is equals to 400, if mean is equals to 400, now can you tell what is the first variation taking place? 200 is the first observation and the mean is 400. That means either a positive variation or negative variation. So the observation is 200 and mean is 400. So what is the amount of deviation? The amount of deviation, if you observe here, is 200 and 400, means there is minus 200 variation. So negative variation is taking place. That is minus 200 is the variation which is taking place. Can you tell me the next one? That is 300 and 400. What is the variation is there? Even here negative variation is there. That is minus 100. So Can you see the screen? If the screen is visible, okay, fine. Okay. So what do you mean by dispersion? So, and why do we use dispersion? You should be having knowledge about that first. Dispersion first for comparing two different data, and next point to measure the scatterness of the data. How the data is scattered, that is either they have positively scattered or negatively scattered, or there is no variation in the data. So to know that, we need to learn something called dispersion. So dispersion is used to measure the amount of variation. So the mm, important merit of dispersion is nothing but first, it is completely based on averages and it helps to compare, it facilitates to control, and it is used for statistical extension. That means based on dispersion, there are certain concepts which are derived using the concept of dispersion. See here, if you observe, measure of dispersion is completely based on measure of central tendency. Without central tendency, measure of dispersion cannot be learned. So here, the entire concept of dispersion is developed based on the measures of central tendency. Similarly, there are certain concepts which are being developed based on measure of dispersion. Examples are like correlation, regression is completely based on measure of central tendency and measure of dispersion. So based on these two concepts, your correlation, regression concept has been developed. And if you observe index number is being developed partially with measure of central tendency. That is first measure of central tendency, arithmetic mean and geometric mean. Based on these two, the index number has been developed. So basis under statistics is nothing but measure of central tendency and measure of dispersion. Under measures of dispersion, there are two measures of dispersion. Number one, that is absolute measure, and number two, it is relative measure. So there are two measures of dispersion, two types. The two types is nothing but absolute measure of dispersion, and the next measure is relative measure of dispersion. Absolute and relative measure of dispersion. So absolute measure of dispersion is completely based on central tendency. So the differences between absolute and relative measure. Under absolute measure is nothing but which is completely based on central tendency. Without central tendency, absolute measure cannot be derived. But when you come towards relative measure is not completely based on central tendency. Therefore, this is one comparison. And the next one is, see, we are learning dispersion for comparison purpose. But under absolute measure, it was again difficult to compare. Under absolute measure, again it was difficult to compare. That is why again advanced concept which is based on the dispersion was relative measure. So for comparison purpose, absolute measure was not used, by which we need to learn something called relative measure. So here the next differences what you can write is absolute measure cannot be used for comparing. So it cannot be used for comparing, but when it comes towards relative measure is used for comparing the observation. So this is one more differences which you should know. This absolute measure cannot be used for comparing, but when it comes towards relative measure is used for comparing the two different data. And the next point is it is easy to compute and it takes time and it is little difficult to compute. Okay, it is easy and it is difficult to compute. Now, under absolute measure, the first absolute measure is nothing but range, and the respective relative measure for range was coefficient of range. So you need to study absolute measure along with that relative measure also to be studied. When you study range, along with the range we need to study something called coefficient of range. The next absolute measure is nothing but mean deviation. So what it is mean deviation. So along with the mean deviation, you need to learn something called coefficient of mean deviation. So coefficient of mean deviation is nothing but it is the relative measure of dispersion. And the next point is range, mean deviation is done. The next one is standard deviation. So standard deviation is also called as ESD, and which can be also written as sigma. So standard deviation and its relative measure is nothing but coefficient of standard deviation, or we can also call as coefficient of variation, COV, that is coefficient of variation. And the last measure of dispersion, under which absolute measure is nothing but mean deviation, and corresponding to that we need to study something called coefficient of mean deviation. So these are the four, sorry, quartile deviation, and the corresponding relative measure is nothing but coefficient of quartile deviation. If you study the four concepts of absolute measure along with their relative measures, this chapter is completed. So this chapter is completely based on range, coefficient of range, mean deviation, coefficient of mean deviation, standard deviation, coefficient of variation, quartile deviation, and coefficient of quartile deviation. So we have discussed what do you mean by dispersion, and we have also discussed why we need a dispersion and the types of dispersion. Under the two types are there, absolute and relative. Under absolute, there are certain different types. Based with along with that, the respective relative measures are also being studied. Is it clear till here? Can we go to range? Can we start with range? Okay. Now with the range. Now the first measure of dispersion is range. How to calculate range, or what do you mean by range? Range is nothing but the difference between the highest value and the lowest value. The difference between the highest and the lowest value is considered as range. So let us give an example. First, the example is 20, 21, 29, 11, 13, 16, 18, 9, 25, 24, 25, 26, 29, 31, 33, 32, 33, 29, 79, 50. So these are the given set of observations. What kind of observations are they? Are they raw data or discrete data or continuous data? Just numbers are written, it is raw data in the nature. Now, in case of raw data, how to ascertain range? In case of raw data, range can be ascertained as what is the highest value? Can you check the highest value? Highest value in the given set of observation. What is the highest value in the given set of observation? The highest value in the given set of observation is 79. Similarly, what is the lowest value in the given set of observation? The lowest value in the given set of observation is nothing but, is it 11? No, it is 9, absolutely correct. The lowest value in the given set of observation is 9. So how to determine range? Range can be determined as difference between the highest value and the lowest value, that is nothing but 79 minus 9. If you do, you'll be getting the range. So in this case, what is the range? The range is nothing but 79 minus 9, that is nothing but 70 is the range. Now when you study range, along with that we need to study the coefficient of range. How to ascertain coefficient of range? Very simple. Highest value minus lowest value divided by highest value plus lowest value. Same concept, that is highest value minus lowest value divided by highest value plus lowest value. The entire factor should be multiplied by 100. Why? Because range or the coefficient of range is always expressed in percentages. Okay, there are degree of uh, relative measures are generally expressed in percentage, therefore you can multiply with 100. So in this case, how to calculate the coefficient of range? So coefficient of range can be highest value is 79 minus the lowest value is 0.9 divided by highest value plus lowest value, that is highest value is 79 plus the lowest value is nothing but 0.9. The entire factor to be multiplied by 100. So by doing this, you will be getting the coefficient of range, that is equal to 70 divided by 79 plus 9. How much is that? 79 plus 9, that is okay 88, and multiply the entire factor with 100. If you multiply that, you will be getting the coefficient of range. How much is that? 70 by 88 into 100. Okay, it is 79.54%. It is 79.54%. That is your coefficient of range. This is how we calculate range and coefficient of range in case of raw data. Very simple. In the given data, recognize which is the highest value. Similarly, the given data, recognize which is the lowest value. Take the difference between them. That difference will be your range. Similar way, how to calculate coefficient of range? Highest value minus lowest value divided by highest value plus lowest value. Multiply the entire factor with 100. You'll be getting the coefficient of range. This is with respect of raw data. Now let us discuss with respect of discrete data. X and F is given. The frequencies are like the values are like 0, 10, 20, 30, 40, 50. So these are the values, and the respective frequencies are 29, 39, 49, 30, 19, 11. Now they'll ask you to calculate range and coefficient of range. How to calculate range and coefficient of range? So in this case, how to calculate range? Highest value minus lowest value. What is your highest value? What is the highest value? It is same like in raw data how we did, same like that. Check the given observation. X is the given observation. Your concentration will always be towards the observations. F is frequency. So whenever with respect of range you study, here frequency will nowhere be discussed. Only we have to focus your only on observation. So your observations are here 0, 10, 20, 30, 40, 50. Your highest value in the given set of observation is 50 minus the lowest value. The lowest value here is 0. So 50 minus 0 is 50 only. Therefore, your range is 50. And can you tell me your coefficient of range? How to calculate the coefficient of range? See, coefficient of range here will always be equal to highest value minus lowest value divided by highest value plus lowest value. The entire factor to be multiplied by 100. By doing this, you will be getting the coefficient of range. That is nothing but 50 divided by 50 multiplied by 100. So you will be getting how much percent? Yes, it is 100% is your coefficient of range. That is 100. So this is how we do the problem in case of discrete data. So the last concept is in case of continuous data, how to calculate range. So in case of continuous data, range can be ascertained as follows. That is nothing but, let me give an illustration to you. That is, class interval is given and the frequency is also given. So the class interval is nothing but 10 to 20. Then 20 to 30, then 30 to 40, then 40 to 50, and 50 to 60. So what kind of class interval is it? What kind of class interval? Yes, it is continuous only. Under continuous, what kind of class interval? It is a continuous data. Under continuous data, what kind of class interval is it? Is it inclusive class interval or exclusive class interval? Is it inclusive or exclusive? How many time I have informed you, and whenever the class interval are inclusive with the nature, we need to convert it into exclusive, and then only we will solve the problem. When this is not inclusive, this is exclusive class interval. Why it is exclusive class interval? Why? Because here, see, I have written the class interval as 10 to 20. As I have written the class interval as 10 to 20, does it mean that all from numbers are from 10 to 20 are included here? No. Why? Because 10 to 20, what is the class width? Can you tell the class width here? The class width here is 10. Yes or no? Do you agree with that? The class width is 10. Yes. Okay. If the class width is 10, that means 10 to 20. So how many numbers are there here? 10 numbers should be there. That numbers are starting from 10. So that means 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. At 19, you are getting 10 values. That means number 20 is just written here, but it is not existing here. Number 20 is there in the second class. Understand that point? Did you got my point? Whenever whenever the upper limit is not included in the respective class, that circumstances the class interval is said to be as exclusive class interval. Whenever the upper limit and the lower limit both are included in the same class, then it is considered as inclusive class interval. I'll give an example even that. So here I want you to calculate I want you to calculate range and coefficient of range in both the case. That is class interval is given and frequencies is given here also. That is nothing but the class interval is 0 to 9, then 10 to 19, then 20 to 29, then 30 to 39. The frequencies for that is again 10, 20, 15, 90. If you observe here, in both the situations, 10 to 20 is written, but the numbers are not from 10 to 20. The numbers are just from 10 to 19 is only existing in first class, and similarly 20 to 29 are only existing in the second class, but number 30 is included in the next class, by which it is considered as exclusive class interval. Whenever any upper limit or lower limit are not included in the same class, that should be considered as the exclusive class interval. Here, if you observe under the second example, can you tell what is the width of the class? What is the width of the class? How to ascertain the width of the class? Subtract the lower limit with lower limit or upper limit with upper limit. Subtract the lower limit with the lower limit and subtract the upper limit with upper limit. See, the lower limit of the first class is 0. The lower limit of the second class is 10. So what is the width of the class? You people are telling 9 and then you are telling 10. Similar way, the upper limit is 9 and here the upper limit is 19. So what is the width of the class? Width of the class is 10, not 9. And there are 10 numbers are there. That is from 0 to 9. If you count 0, 1, 2, 3, 4, 5, 6, 8, 9. So, 9. So 1 minute students. So yes. So we were discussing how to calculate range in case of inclusive class interval and exclusive class interval. At least now you got the idea about the inclusive class interval and exclusive class interval. Both are different. So inclusive class interval and exclusive class interval. So let me give another example. Do tell me whether it is inclusive class interval or exclusive class interval in the nature, and then try to solve the problem. So class interval and the frequencies are as follows, that is 0 to 5, then 5 to 10, then 10 to 15, then 15 to 20, then 20 to 25. The respective frequencies are 10, 12, 13, 18, and 10. So these are the respective frequencies. Then the next data is to you is 1 to 9, then the 1 to 8, then 9 to 16, then 17 to 24, then 25 to 32. The frequencies are 4, 12, 17, 7. So these are the two examples given to you. Can you tell what kind of class interval is first one? Yes, first one is exclusive class interval. Absolutely correct. Then the second one is, inclusive class interval. Absolutely correct. So why? Because here, if you analyze the question here, 0 to 5 is given, but is the number 5 is included in first class? No, number 5 is included in the second class. So this is considered as exclusive class interval, and here both the upper limit and lower limit of the class is included in the same class interval. Therefore here this is considered as inclusive class interval. Can you tell me the width of the class? What is the width of the class for first one? What is the width of the class for the second one? What is the width of the class for the first and what is the width of the class for the second? So the width of the class is 5 for the first one, and what is the width of the class for the second one? For the second frequency is yes. The second one is width of the class is 8. Okay, absolutely correct. So now, what is the range for the first one? Sir, how to calculate range? Very simple. Consider the lower limit of the first class as the lower limit value, and consider the upper limit of the last class as the higher value. So we need highest value and the lowest value. So consider the highest value is nothing but consider the upper limit of the last class as the highest value. Similarly, consider the lowest, that is lower limit of the first class as the lower limit or the lower value. So in this case, what is the highest value? So in this case, what is the highest value? The highest value will be 25, and your lower limit will be 0. That means here, what is the range? The range will be 25. That is 25 minus 0 is 25. Then what is the coefficient of range? So 25 divided by 25 multiplied by 100, I think you'll be getting 100%. So that is your coefficient of range. Now in the second example, I want you to calculate the coefficient of range and range. Calculate the range. First calculate the range. What is the range? Is it 31 or 32? Chetan 32, Prithviraj, Deepti 31. Okay, many are answering 31. Srivatsa 31, Vaibhavi 31. Okay, okay, 31, 32.5, 31, 31. Okay, I got three answers. Okay, let me check which answer is right. We have discussed even in the arithmetic mean, whenever any class interval is inclusive in the nature, first duty is to convert that into exclusive class interval and then solve the problem. Same property holds good even here. That is nothing but whenever the given class interval is inclusive in the nature, first convert it into exclusive. How to convert it into exclusive? That means subtract 0.5 from all the lower limits. Similarly, add 0.5 to all the upper limit. So by doing that, your class intervals will be subtract 0.5 from all the lower limits. If I subtract 0.5 from all the lower limits, what is the value you get? 0.5, and add 0.5 to all the upper limits. So when I add 0.5 to all the upper limits, the values will be 8.5. So can you tell me the next frequency? Subtract 0.5. So if I subtract 0.5, that is 8.5, and the next number will be 16 plus 0.5. So add 0.5 to the upper limit and subtract 0.5 from the lower limit, so that you are converting an inclusive class interval into exclusive class interval. After conversion of inclusive class interval into exclusive class interval, then solve the problem. We know how to solve the problem in case of exclusive class interval. How to solve the problem in case of exclusive class interval? First step, take the lower limit of the first class as your lowest value and take the upper limit of the last class as the highest value. So what is the lower value? That is nothing but the lower value will be 0.5. Similarly, what is the highest value? Highest value in the given question. The highest value will be 32 last. That is the upper limit of the last class. Upper limit of the last class is 32.5. So take that as 32.5. So your lower value is there and the highest value is there. So now I need to calculate range. How to calculate range? Range will be equal to difference between the highest value and the lowest value, that is equal to 32.5 minus 0.5, that is equal to 32. Similarly, can you tell me the coefficient of range? How to calculate the coefficient of range? Highest value minus lowest value divided by highest value plus lowest value, the entire thing, multiply by 100. By doing this, you'll be getting the coefficient of range, that is equal to 32 divided by 32.5 plus 0.5 is 33. Entire thing multiply with 100, you'll be getting 96. Yes, absolutely correct. So 96.96. So this is your coefficient of range. Is it clear till here? So we have discussed what I mean by dispersion and why we need dispersion, and we have also discussed the different types of dispersion, that is different measures, that is number one absolute measure and the number two is relative measure. So under that, we have discussed the first part, range, and how to calculate range and how to calculate coefficient of range. Is it clear till here? Thank you for watching my channel. So do subscribe to get updated whenever the class is conducted. So do get subscribed and watch and keep supporting always. Thank you all.